aspect of today's talk. Okay, if you are provided some data points, and among those data points, show the values are missing, then how we can find them out or we can approximate them. So this is your second discussion. So here we once again start solving a question. And the statement of the question is, okay, you are given a set of points Okay, so here we are giving a set of points, and the points are, of course, in the form of x and y. The values of x are rising from 16, 18, 20, 22, 24, and 26. And the corresponding values are 43, 89, and dash, 155, and 268, and 388. So these are the values which are given to you, and the requirement is you have to find this missing value among this set of points. So how we can find this value out? That the method or the technique basically we're using, you have studied in our previous lecture when we were talking about the operators. So here we should be using the operators in order to find out this value. Now the known values are 5. So from here you can understand that we can approximate this set of points, or we can approximate the value of y with the fourth order polynomial. So this indicates that the fifth order difference or the higher difference will be all 0. So we shall be making use of this indications from the information. So here we take, before putting that difference equals to 0, let me first highlight the values. So here x0 is 16, of course this is 16, x1, x2 is 20, x3 is 22, x4 is 24, and x5 is 26. 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5. So these are the values. And the corresponding values of y are, y0 is 43, y1 is 89, y2, that is you have to find out, y3 is 155, y4 is 268, and y5 is 388. So now we have to make use of these values in order to find out this missing term. So here, as I told you, that we are given up to 5 values, so we can approximate the values y up to the fourth order polynomial. So the fifth order difference, I am putting them equals to 0. So fifth order difference will be equals to 0. Now when we were studying about the operators, there we have constructed a relation of the forward difference to the shift operator. So here we shall be using the relation of the forward difference to the shift operator. So this can be replaced by e minus 1 raised by 5 y0 equals to 0, because we know that del is equals to e minus 1. Now you can expand it. You have to expand it by using the polynomial. You can expand it taking the 5 terms, 5 times multiplication of e minus 1 with each other, or you can use some other ways to construct the ultimate result. So here we are going to expand it, and after expansion you will be obtaining the result of like this: e5 minus 5e4 plus 10e3 minus 10e square plus 5e and minus 1, and all are going to apply over y0. Now you can apply these operators over y0, so we can write it in the form of e5 y0, 5e4 y0, 10e4 y0, 10e2 y0, 5e y0, and y0 equals to 0. So here you can see we have just applied all these operators over y0. Okay, now we are going to use the definition of the forward difference operator. Oh, sorry, I have to use these values. These should be over here in order to use them. Okay, let me write it again for you. The